Migraine headaches are horrible, and if you suffer from migraines, you know exactly what I'm talking about. Although full disclosure, right up front, I've never had a migraine. I don't even get headaches that often, and when I do, I usually just drink some water and go for a quick walk, and it usually clears up. But migraines are a different beast. I've never had anything that compares to what people describe as a migraine. They can't be cleared up with a glass of water and a stroll. They linger, and they last for a long time. Sometimes hours, and they're very painful. The migraine headache is characterized by intense and debilitating pain in, usually, one side of the head. During a migraine, the person becomes nauseous and extremely sensitive to light and sound. Even dim lights are perceived as extremely bright, and even soft sounds are perceived as screamingly loud and grating. During the migraine, things can get even weirder. Some people report visual hallucinations, like seeing strange shimmering or lights, or seeing objects that aren't there, or not seeing objects that are there. It can be extremely disorienting. Migraines with these visual effects are often called aural migraines, or ocular migraines, as they involve heavy distortion of the visual input. In other words, it messes with your ability to enjoy a stable, normal visual field. Now, recently, there's been a new study that analyzed how patients who suffer from migraines respond to certain visual stimuli. As the researchers showed the subjects visual stimuli, like an image of a striped grading pattern, like just a stack of black lines, they used an electroencephalogram to measure the electrical activity of the brain. And this way, they could observe and record brain activity in response to the visual stimuli. They could see if some brain regions, like the visual cortex or the visual association cortex, were being overexcited by certain stimuli, and they could see how fast it took the brain to respond to the stimuli and build up this overexcitation. The striped grid pattern that they used, or this grading pattern, is really interesting. So your brain has a bunch of different neuron clusters that process different aspects of what you're seeing. Some neurons process edges, like the edge of objects, while others process surfaces. Some process vertical lines, while others process horizontal lines, and others process angled lines. Some neurons process colors, others process brightness and black and white. It's been established that seeing strong edges in a high-contrast, high-frequency repeating pattern, like a grate or a grid, or some other series of bars on a high-contrast background, can actually cause visual distress and lead to migraines in people who are susceptible to them. Dr. Terence Chun Huen Feng was the lead author of the study, and he said, quote, "Most migraineurs also report experiencing abnormal visual sensations in their everyday life. For example, elementary hallucinations, visual discomforts, and extra light sensitivity," unquote. This was the general basis that led him to look at visual stimuli specifically as a trigger for migraines. After looking at their data, the researchers determined that for some people susceptible to migraines, seeing high-frequency grid patterns could actually trigger a migraine. They found that the parvocellular system, which is a group of, it's a neuron cell system in the brain, they found that the parvocellular system, which includes nuclei that process contour and texture, were overexcited by the high-frequency grading images. This was paired with an imbalance in the connections to the magnocellular system, which is an adjacent set of neurons that form a visual system that processes contrast and brightness. Curiously, they also found that some people who don't get migraines, but were susceptible to cortical hyperexcitation, reported the onset of headaches after seeing the visual stimuli. Dr. Ali Mazahiri was a senior author on the paper, who said, quote, "Our study provides evidence that there are likely specific anomalies present in the way the visual cortex of migraine sufferers processes information from the outside world. However, we suspect it's only part of the picture, since the same patterns of activity can also be seen in non-migraineurs who are sensitive to certain visual stimuli," unquote. So this study is definitely scraping the tip of an iceberg. There's a lot here that we could dig into. I mean, the study itself is pretty beefy, and there's a lot there that I didn't cover. It would be extremely complicated because it's all about different visual processing systems, and how some systems modulate and regulate other systems, and what happens when there's a disconnect or an imbalance there. The key detail to take away here, though, is that in some patients with migraines that can be triggered by these high-frequency patterns, there appears to be an imbalance in activity or an uneven distribution in the number of connections between the parvo and magnocellular visual processing systems. There's an imbalance in how the brain processes the contrast and brightness of high-frequency images, and that imbalance can lead to subsequent hyperactivity in the brain, which then manifests as all of the terrible symptoms of a migraine. This is a rich area for future research, and I'm excited to see what comes out of it. I mean, perhaps one day we'll have developed a brain stimulation therapy that counteracts the imbalances and effectively stops migraines. That would be pretty fantastic.